using the standard system calls open, read, and write. Each file access requires a system call and disk access. Alternatively, we can use the virtual memory techniques discussed so far to treat file I/O as routine memory accesses. This approach, known as memory mapping of file, allows a part of the virtual address space to be logically associated with the file, as we shall see. This can lead to significant performance increases. Memory mapping of file is accomplished by mapping a disk block to a page in memory. Initially, access to the file proceeds through ordinary demand paging, resulting in a page fault. However, a page-sized portion of the file is read from the file system into a physical page. Subsequent reads and writes to the file are handled as routine memory accesses, manipulating files through memory rather than incurring the overhead of using the read and write system calls simplifies and speeds up file size and usage. Note that writes to the file mapped in memory are not necessarily immediately read to the file on disk. Some systems may choose to update the physical file when the operating system periodically checks whether the page in memory has been modified. When the file is closed, all the memory mapped data are written back to disk and removed from the virtual memory of the process. Some operating systems provide memory mapping only through a specific system call and use the standard system calls to perform all other file I/O. However, some systems choose to memory map a file regardless of whether the file was specified as memory mapped. Multiple processes may to be allowed to map the same file concurrently to allow sharing of data. Writes by any of the processes modify the data in virtual memory and can be seen by all others that map the same section of the file. The virtual memory map of each sharing process points to the same page of the physical memory, the page that holds a copy of the disk block. This memory sharing is illustrated here. In this, we can see as a process A, this is the process A virtual memory space. This is the process B virtual memory space. And you can see page 1, 2, 3 till 6 are mapped to the same physical frame here. Okay, so process A and process B share this the file, and this is the physical memory. This is the disk, hard disk on the hard disk, and you can see this they share the same file. Okay. Under this scenario, processes can communicate using shared memory by having the communicating processes memory map the same file into their virtual address space. And the memory mapping system codes can also support copy on write functionality, allowing processes to share a file in read-only mode, but to have their own copies of any data they modify. The processes involved might use some mechanisms to achieve mutual exclusion.